Hey everybody, this video is going to be going over the Tuesday column on week 3's homework, which is solving inequalities using multiplication or division. So Mondays was about addition or subtraction, this will be about multiplication or division, and if you need to refer back to your notes, that is the 4.3 notes, parts 1 and 2. So before we start going over the example problems, we need to talk about two specific properties, just like we talked about in Monday's video. We talked about the addition and subtraction property of inequalities. Here we're going to talk about the multiplication or division property of inequalities, because those are inverses of each other. They pair with each other. But the thing about the multiplication division is that it gets a little different, or there's an exception with the negatives, and you'll see what I mean by that in just a little bit. So I've gotten it written down here for you. I've got case number 1 is multiplying or dividing sorry, let me catch it's 12:20 a.m. so I'm a little tired. Multiplying or dividing property of inequality with positive numbers. So notice how I said that it's with positive numbers. That means that there's going to be a different case with negative numbers. So this reads that if you multiply or divide an inequality by the same positive number, this keeps the inequality true. So we're already used to hearing that if you add or subtract something to both sides, it keeps it true. If you multiply or divide an inequality by the same positive number, it keeps the inequality true, meaning that the symbol does not change. So I'll make a little note of that. Symbol, no change. So if you're multiplying or you're dividing an inequality by the same positive number, the symbol, the comparison symbol, does not change. However, if you decide to multiply or divide the multiplication division property of inequality with negative numbers, then, as you can see here, it reads, when multiplied by the same negative number, the comparison symbol must be reversed for the inequality to remain true. So when you're multiplying by the same positive number, as in case 1, there is no change, but in case 2, when you multiply or divide by the same negative number, there is a change. Symbol reversed. Which means that if it's a greater than, it's going to turn into a less than. Or if it's a greater than or equal to, it's going to turn into a less than or equal to. So if you multiply or divide by the same negative number, you're going to have to make a reverse in the comparison symbol. But if it's the same positive number, then the symbol does not change. So I'm going to move that over to the side and we'll go over some examples together. So let's take a look at the first problem here. We've got that x divided by 5 is less than negative 3. So x is divided by 5, which means that we're going to want to use the inverse operation of division. The inverse operation of division is multiplication. So because those are technically, we call opposites of each other, those are inverse operations. So when I have x divided by 5 is less than negative 3, what I can do to both sides is I can multiply both sides by 5, since that's the number that is next to the variable. I can multiply both sides by 5, and this multiplication and this division of the 5s will cancel each other out, just like it does with addition or subtraction. Those will cancel each other out to give you a 1, and I'll show you why that is. So if I do 5 times x, that gives me 5x. And then since there technically is a number on the bottom of this 5, it's a 1. If I do 1 times 5, that's going to give me 5, which gives me 5x over 5. Now, I know that 5x divided by 5 actually cancels out these 5s. 5 divided by 5 is just going to be 1x, which we write as just x, is going to leave me that x is less than whatever negative 3 times 5 is going to give me. So x is less than negative 15. So x, therefore, now that I've solved it out, x is all values less than negative 15. So we didn't have to make any sort of changes to the symbol on that one because we multiplied both sides by the same positive number. And so we didn't have to make any changes to the symbol. But let's take a look at number 2 and see how that one is different. You can see here that in number 2, the number that we're going to have to manipulate is a negative number. This negative 2, we're either going to have to multiply or divide for this, since that's what the instructions are at the top. And so because this is y divided by negative 2, what we're going to want to do to both sides is we are going to want to do the inverse of division, which is multiplying by negative 2. And y divided by negative 2, or y over negative 2 times 2, we can turn that into a fraction, results in negative 2y over negative 2, which then turns into just y. And so you should see here that these are just the steps that I'm showing that as to why we get y on its own, but as long as you're doing the right inverse operation, you should always end with just the variable on one side on a one-step equation. And then here I'm going to have, now notice how I just made a mistake and I just caught it. This symbol is no longer going to be a less than symbol. Because I multiplied both sides by a negative number, this is actually going to turn into a greater than symbol because it's a negative. So just make sure that you're always watching those negatives. I know you guys got me saying that all the time during first semester, so just make sure that you're also still watching those negatives. Because I multiplied both sides by a negative number, I have to flip, or I have to reverse the symbol. So this less than sign turned to a greater than sign. And then on the left side, negative 2 times 0.5, or negative 2 times a half, is going to give me a negative 1. And so my answer becomes that y is all values that are less than negative 1. Whoops, what the heck? Well, so much for this. Sorry about that. So remember we talked about how you have to make sure that you're reading this properly. I can see that the mouth of the Pac-Man is pointed towards the negative 1, which means that the negative 1 is bigger than the y, or in other words, y is less than negative 1. Y is all values less than negative 1. Okay, so remember for these next three, you're going to be multiplying or dividing. So if the original problem is a multiplication, like it is in number 3, you're going to be doing division. If you have to divide or multiply by a negative number, what are you going to do differently? You're going to flip or reverse the comparison symbol after you multiply or divide by a negative number. If you're multiplying or dividing by a positive number, the comparison symbol does not change. And then just make sure that you're doing your math correctly, and you should be set for these ones.